Initially, there are methods in which we determine when we solve simultaneous equations, and that is elimination method, we have substitution method, and we have graphical method. So the fourth method is using the matrix method. So I will take you through the steps one by one. So let's look at the solution. Step one, if you look at these two equations, the variables are not in the same order. Therefore, we must ensure we rewrite so that the variables are in order or are in the same order. So we shall rewrite the first equation, which is y minus 4x. We shall begin with negative 4x. So that one will be negative 4x, and then plus y is equal to negative 3. And then we obtain the second equation, which is 4x plus y is equal to 5. So that the x are in the same position while the y's are in the same position. The next step is we write the coefficient matrix. So the coefficient matrix here is we extract the coefficients of x and y. So the coefficient of x in the first equation is negative 4. The coefficient of x in the second equation is positive 4. The coefficient of y in the first equation is 1. The coefficient of y in the second equation is 1. So that is our coefficient matrix. Then we multiply the variable matrix. The variables here are x and y. And we equate it to the constant matrix, or the constants matrix, which is negative 3 and 5. So this is the matrix equation now. The next step, we determine the inverse of the coefficient matrix. So to determine the coefficient of matrix, we must get the determinant of this matrix, and then find the reciprocal of the determinant of this matrix, and then multiply the inverse of the determinant of this matrix with this matrix, with the digits in the leading diagonal interchange and the digits in the minor diagonal, the sign changes. So we go to the determinant of the coefficient matrix. The determinant will be 1 times negative 4. Subtract 4 times 1. You will get negative 8. So the inverse of this matrix will be, the inverse of the matrix will be the reciprocal of determinant, which is 1 over negative 8, multiplied by interchange of digits in the major diagonal will be 1, negative 4, and then the sign of the digits in the minor diagonal will change, it is negative 1, negative 4. And if you multiply, you will get negative 1 over 8, positive 1 over 8, positive 1 over 2, positive 1 over 2. So that is our inverse. Once we get the inverse now, we take the inverse, then we multiply with both the left hand side and the right hand side of the matrix equation. So here we shall have inverse, which is 1, negative 1 over 8, 1 over 8, a half, multiply this left hand side, which is negative 4, 1, 4, 1, multiplied by x, y, is equal to the same inverse, which is negative 1 over 8, 1 over 8, 1 over 2, 1 over 2, multiplied by negative 3, 5. Now, the trick here is that you don't need to burden yourself with the multiplication of the two matrices one by one. Common knowledge tells us that if you multiply an inverse of a matrix with the same matrix, it gives you identity matrix. So multiplying this inverse or this matrix by its inverse will give us identity, which is 1, 0, 0, 1. Then multiply by x, y is equal to, if you multiply this matrix by this matrix, you multiply the row by the column. Then you multiply this row also by this column. We shall get 1, 1. Now, multiplying identity matrix by the value of the matrix is just like, this identity matrix is just like 1. So 1 times xy will just get xy is equal to 1, 1. Therefore, it implies that the value of x is 1 and the value of y is 1. And we have solved the simultaneous equations using the matrix method.